Good morning. I'm Zener. In this lecture, we are going to discuss about VI characteristics of Zener diode, and then we will see how Zener diode is working as an voltage regulator. This topic is present in the subject electronic devices and circuits. Zener diode. The Zener diode is a special type of diode that is designed in the reverse breakdown region. An ordinary diode operated in this region will usually be destroyed due to excessive current. This is not the case for the Zener diode. Zener diode reverse breakdown voltage. The Zener diode has a well-defined reverse breakdown voltage at which it starts conducting current and continues operating continuously in the reverse bias mode without getting damaged. Here is the representation of a Zener diode. The picture represents the Zener diode. In the Zener diode, we are having a black ring. The lead which is nearer to the black ring is the cathode terminal and the other lead is the anode terminal. Let us see the appearance and schematic symbol of Zener diode. Here is a representation. The appearance of the Zener diode is indicated. The Zener diode is having two terminals. They are cathode terminal as well as the anode terminal. It is indicated here. In this Zener diode, you will be having a black ring. The terminal which is nearer to the black ring is the cathode terminal and the other terminal is the anode terminal. And the schematic symbol of the Zener diode is also indicated here. Here, the plus symbol indicates the positive terminal and the minus symbol indicates the negative symbol. It is indicated. The direction of the normal diode current flow is indicated here. Characteristics of Zener diode. A Zener diode operates just like a normal diode when it is forward biased. However, when connected in reverse biased mode, a small leakage current flows through the diode. As the reverse voltage increases to the predetermined breakdown voltage, that is V suffix Z, then current starts flowing through the diode. Doping of Zener diode. Zener diode includes an individual and heavily doped PN-junction, which is intended to perform in the reverse bias direction when a particular voltage is reached. This causes a very thin depletion layer. As a result, a Zener diode has a sharp reverse breakdown voltage V suffix Z. Working principle of Zener diode under forward bias and reverse bias condition is shown here. During the forward bias condition, the width of the depletion region is decreasing, but in reverse bias condition, the width of the depletion region increases very well. This is indicated in this animation. Here is the representation of a VI characteristics of Zener diode. The Zener diode is a special purpose device. It is used for reverse bias mode. Under the reverse bias mode, after the Zener breakdown region, the output voltage is a constant one even though the current in the circuit increases. This is indicated in this curve. Let us see the Zener breakdown process. Valence electrons which break free under the influence of the applied electric field can be accelerated enough that they can knock loose other electrons, and the subsequent collisions quickly become an avalanche. This process of sudden release of electrons is known as Zener breakdown. Zener breakdown occurs in heavily doped junctions in which the transition from the p side to the n side is very abrupt. Under these conditions, the potential barrier separating carriers on the two sides of the junction is very narrow, and a quantum mechanical process called tunneling can take place now. This is indicated here. Zener breakdown representation is indicated here. Here we have a PN junction and a wide depletion region is indicated here. So in the p-type portion nearer to the junction we have negative ions. In the n-type portion nearer to the junction we have positive ions. That negative ions and the positive ions hit the atom. That is, free electron hits the atom at high speed. Because of that, new electron-hole pair is generated. This is indicated in this diagram. Due to this, Zener breakdown occurs. That is due to this process. Zener breakdown. The Zener breakdown mainly occurs because of a high electric field. When the high electric field is applied across the PN junction diode, then the electrons starts flowing across the PN junction. Consequently, expands the little current in the reverse bias. When the electron moving enhances beyond the diode rated capacity, then the avalanche breakdown will occur to break the junction. Therefore, the flow of current in the diode is incomplete. The diode will not damage the PN junction. However, avalanche breakdown will damage the junction. Here is a representation of a Zener breakdown and the avalanche breakdown. This avalanche breakdown occurs in the normal PN junction diode. Zener breakdown occurs in the Zener diode. These two breakdowns occur when the diodes are reverse biased. This is indicated here. Zener diode as voltage regulator. A Zener diode can be used as a voltage regulator to provide a constant voltage from a source where voltage may vary over sufficient range. The circuit arrangement is shown in figure. Here is a connection that indicates the Zener diode that is used as voltage regulator. In this diagram, the Zener diode is functioning in a reverse bias mode. That is, the negative terminal of the Zener diode is connected to the battery's positive terminal, and the positive terminal of the Zener diode is connected to the negative terminal of the battery. And across the Zener diode, the load resistance RL is connected. This is indicated here. And the VA characteristics of the Zener diode is also indicated in this diagram. The Zener diode of Zener voltage V suffix Z is reverse connected across the load RL. The output is taken across the load RL, which is a constant voltage. The series resistance Rs absorbs the output voltage fluctuations so as to maintain constant voltage across the load. When the circuit is properly designed, The load voltage V0, which is equal to V suffix Z, remains essentially constant even though the input voltage V suffix DC and the load resistance RL may vary over a wide range. Voltage drop across the RS is equal to VDC minus V0. Current through the RS is I, that is equal to IZ plus I suffix L. Now applying Ohm's law, we have R suffix S is equal to V suffix DC minus V0 divided by IZ plus IL. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.